Okay, this is the Algebra 1 video for 4.2, Patterns and Linear Functions. So here our objective is to identify and represent patterns that describe linear functions. So in a relationship between variables, there's going to be a dependent variable, and that's always going to change. And then in response to another variable, which is the independent variable. So the dependent variable depends on the independent variable. The most common independent variable would be time, right? Time changes independently. Nothing, time just goes on no matter what. Other things are dependent on time. So time is a good example of an independent variable. Values of independent variables are called inputs, and then values of dependent variables are called outputs. And so you can also think about a function as like a function box or a function machine. I think we've talked about this before, right? So you input a value, that's kind of like your x values or your independent variables. And then the function box does something to it, say like it multiplies it by 2 and then adds 3. It's kind of like the function. Like this is why it's inside, it's an input. And then once it does that to it, it outputs. Right? And the output is your y or your output or your dependent variable. Anyway, we haven't gotten quite there yet, but that's kind of how you think about how these relationships work. That would be an example of a function. Anyway, here's the first problem that we're going to discuss a relationship between. So in this diagram, what's the relationship between the number of rectangles and the perimeter of the figure that they form? Represent this relationship using a table, words, equation, and graph. Okay, so I think the best way to start with this is a table, right? So for each situation, right, we're talking about the relationship between, right, our variables are going to be number of rectangles versus perimeter of the figure that it forms. Okay, so the number of rectangles, this is my independent variable, right? You're just adding on another rectangle, so that's not dependent on anything. The perimeter does depend on however many rectangles there are. So this is my dependent variable. Okay, so in this table, we're going to call the independent x and the dependent y. So for my table, let's make a table of x values and y values. So here my x, this is my x, right? 1, 2, 3, 4. So let's do for each situation. The independent is easy because it just goes up by 1 each time and adds a rectangle. So here's my not so fancy table. Okay, and then y is the perimeter. So let's see here. This perimeter, right, if this is 6 and this is 1, this is 6 and this is 1. So that's 12 plus 2, which is 14. Okay, and then this still has your 6, and this is 1 and 1. You still have your 12, 13, 14, 15, 16. This adds another 2. So every time you add a rectangle, you're adding 2, right? You start with your 12, so you're going to keep this 12, and then 1, 2, 3, 4, 5, 6, 7, 8, plus 12 is 20. Okay, so that is the table. And so in words, we can say, there's always 2 sides that add to 12, and then 2 is added to the perimeter each time a new rectangle is added. Oh, sorry, I won't do this again. I'll just push pause and type it so you don't have to wait for me to write it. But let's think about what that says in real time. There's always 2 sides that add to 12, right? You're always going to have these 2 sides. So you always have 12. And then each time you add a rectangle, there's going to be 2 to the perimeter, right? So with 1, you have your 12, and then with 1 rectangle, you add 2, 14. Then you have your 12, there's 2 rectangles. So, and so you have 1, 2, 3, 4 plus the 12. So every time you add another rectangle, you add 2 to the perimeter. So that helps us with our equation. With the equation, you're always going to start with y equals, what would it be if it's 0? Obviously, with 0 rectangles, we're not going to have a perimeter. But what is there without a rectangle? That's going to be your 12. Like, what are we starting with? We start with our 12. So then 12, and then you add 2 times, and then whatever changes every time, 2 is what changes every time you multiply that by x. That's kind of like your slope. And this is like your y-intercept, and this is your slope. Y-intercept is going to be when x is 0. In this case, there isn't really a context for x is 0, but just if x was 0, right, you would have 12. And then every time you add a rectangle, you get 2. And so you can see that when you plug in 1, 12 plus 2 is 14. When you add 2, 4, 12 plus 4 is 16. 3 times 2 is 6, plus 12 is 18. 4 times 2 is 8, plus 12 is 20. So you can see that that's the equation there. Okay, and then we have a graph. So the graph, you're just going to, let's put that here. You're just going to do your dependent variable is going to be, your independence on the bottom, so number of rectangles. And then your dependent is on the side, perimeter. And so let's make this, we have to go up to 20. So let's make that 5, 4, 8, 12, 16, 20. And then, and let's make 1, 2, 3, 4. So when you have one rectangle, you have 14, which is here. When you have two rectangles, you have 16, which is here. 3 rectangles, you have 18, which is here. And then 4 is 19. So there's the graph. You can see it goes up by 2 every time. And then we're just doing dots because the perimeter doesn't, there's nothing in between those 2 dots. Okay. So let's see if there's one over here. Okay, so this one is one for you to try. So in this diagram below, what is the relationship between the number of triangles and the perimeter of the figure they form? Represent this. Okay, so do this one. It's pretty similar to what we just did. So try this. Again, you're going to do table, words, equation, and graph. Okay, so press pause, try this on your own, and then check back for the solution. Okay, so for this one, you can see each time another triangle is added, you get 4 more. So that's what our slope is, our 4x. And then if there were no triangles, you would have 6. So that's why, right, if you just subtracted 4 from 1, right, it would be 6. So starting with a perimeter of 6, 4 is added to the perimeter each time a triangle is added. And so here's our equation, and then that is the graph. Number of triangles is our independent x variable, and perimeter is our dependent y variable. So hopefully you got that. Oh, and then here's my function box. A function is a relationship that pairs each input value with exactly one output value. Right, so anytime, whatever that number is that you input, the function does something, and then there's only one output for that. So independent goes in, output, something happens, the function messes with that input, and then spits out an output, which is dependent on whatever was input there. Okay, so here is our next problem. This table shows a relationship between number of photos, x, that you take, and the amount of memory, y, left on your camera's memory chip. Back in the day, there were cameras that the memory would be, I guess phones do the same thing. Every time you take a picture, you have less memory on your phone. Is a relationship a linear function? Describe the relationship using words, equation, and a graph. Okay, so linear functions from a table you can tell is if the x value changes by a constant value, the same number each time, and the y value changes by the same number at a time, then it is a linear function. And the number that the y changes is your slope. And then whatever is your value at when x is 0 is your y-intercept. Okay, so this is how you check this here. You just subtract from, or this just adds 1 each time. 1 minus 0 is 1, 2 minus 1 is 1, 3 minus 2 is 1. So this goes up by 1 each time. Here, right, this is going down. So take, where's my calculator? I can do this without a calculator, but I'm not going to. Take 509 and subtract 512. So, and so it's going down by 3. And you can see each one goes down by 3. So if these all change by the same value, this means it's constant. So these are, constant. So that's where we start. If it's not constant, then this doesn't work. You have to make it so it's constant, or you have to move them around so it's constant. Then you can check these guys. If these are all the same number, that means these are constant. If both are constant, or if you move your x's so that they're constant and you check that your y's are constant, then this is linear. Okay? And so is the relationship a linear function? Yes. Okay, describe the relationship using words. So with the words, let's hear words. As the number of photos goes up, so each time you take, so this is going up by 1. Each time you take a photo, I don't like to use you, what do we say? Each time a photo is taken, The memory card goes down by 3 megabytes, or decreases. So here we would say basically you're saying each time X goes up by 1, Y goes down by 3, but you can kind of put it in words, right? So when X goes up by 1, that means you take a photo. So each time a photo is taken, memory, right, goes down by 3, which is MBs. So the memory decreases by 3 MBs. And so if we write an equation, remember we're going to start with our y-intercept. Y equals my y-intercept, which is 512. And then we're going to, since our slope is negative, we're going to subtract 3 times x. So right, this is going to be your slope if it's constant. And then this is going to be your y-intercept. And so you can easily put that in your y equals mx plus b. And just for these, I always start with b, just because we're starting somewhere and we're adding or subtracting on, which is where your slope is. So this is, in this case, would be b plus mx, where m is negative 3, right? So this is b plus negative 3x, or b is 512. Anyway, that's how you do the equation. Okay, and then the graph, we're just going to do this plot here, and I'll just push pause so you don't have to watch me do it. Okay, so here I didn't talk about dependent, independent. Well, X is your dependent, that goes on here, right? So number of photos. If you want to space them out better, you can, but I had this graph paper here. And then for the memory, right, I needed 503 through 512 on here. So I did this little okay, we're going to skip a bunch and we're going to start at 500. Then each one of these is 3. So it kind of looked clean. Here's our graph. Okay. So try this one on your own. Press pause. You're going to do, say if it's linear or not. If it is, describe the relationship using words, equation, and a graph. So press pause, do this on your own, and then check back for the solution. Then we'll be done. Okay, so here you can see, to check if it's linear, you see that this is constant, so we can keep going. And then we can see this is also constant. It goes up by 2 each time. So yes, it's linear since these are both constant. And then words, this is as simple as it gets. Actually, every time it's going to be something like this, right? Each time X increases by however many is here, usually 1. In our cases, all these ones have been 1. The out point increases or increases if this goes up, decreases if it goes down, and then by whatever that is. So this is saying each time X increases by 1, Y increases by 2. Which is helpful for our equation, which we're going to do b plus mx. B is our y-intercept whenever x is 0, 8. And then our slope is this constant here, so 2 times x. That's our equation. And then here is our graph. I just skipped a bunch and then made each of these 1. So we could get our 8 through 14 on the graph. And I spaced these out a little better just to make it better. And I plotted each point. That's it. Okay, time for practice. Enjoy.